Here we're given two equations. The first one, part A, is x equals the square root of a with a restriction on the range. Y has to be greater than or equal to 0, of course, because you're not going to take the square root, an even index root, of anything that's a negative number. And part B is x equals the absolute value of 2 times y. Then we're asked to answer this question. Do these equations represent y as a function of x? Y as a function of x. Well, let's look at part A. What we want to do here is isolate the y. So we get the square root of y equals x. We turn it backwards. And then to get rid of the square root, we're going to square both sides. That's the inverse operation of the square root. And we cancel the inverse operation on the left, and we get y equals x squared. Does every x that I plug in there, does every x produce only one y partner? That's the question. Does every x produce only one y partner? Well, let's test. Let's say x equals 3. When we use x equals 3, we have y equals 3 squared, which is 9. That's one y partner. Let's test x equals 5. When we plug in 5, we get y equals 5 squared, which is 25. That's just one partner. Okay. How about x equals 0? Does that have only one partner? 0 squared equals 0. Yep. So you notice we are not testing negative x values, and that's because we know that x equals the square root of y. So x equals an even index root, and we know that even index roots, or answers, are always going to be greater than or equal to 0. So x is greater than or equal to 0. That's why we didn't bother to test any of the negative numbers, because we know x equals a principal square root, which is always positive. Okay, so it looks like all the x's we're testing are giving us good results. It looks like all the x's are faithful. Thus, the answer would be yes. X equals the square root of y with y greater than or equal to 0 is indeed a function, because all the x values that we plug into it give us only one y partner. Okay, let's take the equation B and let's write the y term on the left. So we have the absolute value of 2y equals x. Now consider the definition. The definition of absolute value says that the 2y has to equal the x union together with the 2y equals negative x. Okay, so if you know that the absolute value equals a number x, then you know the stuff inside is equal to positive x union together with negative x. Okay, so that implies that y equals 1/2 times x when I solve both sides, when I solve for y. And this one is y equals negative x over 2. Okay, so we've got 1/2 x and negative 1/2 x. That's what we have. 1/2 x and negative 1/2 x for the y's. Let's test x equals 6. Does it have only one y partner? Y equals 1/2 times 6, which is 3. Also, y equals negative 6/2, which equals negative 3. Uh-oh. Right away. We've got the y by itself. We plugged in values for x, and the first one we tested gave us 2 y partners. That implies that we have unfaithful x's. At least this one is unfaithful. That's enough to mess it up for everybody. So that implies that this equation does not represent y as a function of x. No, it's not a function.